in it, but one of the beam broke and everyone is okay, which is the most important. But some of the students are a bit late due to that. So we will start the tech talks in about 15 to 20 minutes. So sorry for being a bit late, but I hope we will be happy to have everyone safe tonight. Thank you.
Good afternoon, everyone. We are starting the Tech Talk soon. Please take your seat. Thank you. Is Physis here? Physis. Politecnico di Milano is here. Thank you. University of Bologna. University of Bologna. Thank you. Messina Energy Boat. UniGe. WannSea. And Technico Solar Boat Energy. Thank you.
So, we are just about ready to start. We are starting today with the Eco Conception Prize, and our first lovely presenters are coming from Milan. Physis, up on stage, please.
Hi everyone, I'm Gabriele Defendini, the Mechanical Technical Director of Physis FPAII.
Hi, I'm Greta, and I'm a member of the structure unit.
Today, I'm here to talk about the project of Physis FPAII. I'm proud of these teams and this work. Our mission is to innovate, create and design solutions that can meet our present needs, but also the long-time performance. So this year, as you can see on the harbor, we are here with a boat that has a cockpit made with full carbon fiber. But if we take a look closer to the boat, we can see a lot of different materials like Kevlar, glass Kevlar, carbon fiber, glass fiber, basalt fiber, and flux fiber. Because we think that every component has the correct materials for each production. One of the biggest challenges of this year was the reduction of overall weights, and so it was necessary to switch to carbon fiber. And this year we worked a lot on the lightweight design because we have an hybrid propulsion, so with hydrogen and lithium batteries. And this system, because it has to be really safe, so there are a lot of parts that are saved. It was necessary to switch to carbon fiber. This year we have reduced a lot the weights, and now I want to tell you the amount of percentage. For example, the cockpit is the 40% less, the longitudinal tubes the 55%, the transom is the 30%, and our custom transmission is the 30%. Now, take a look on the data of the LSE of our boat. Let's go, Greta.
Okay, so for the global warming, the main impact is given by carbon fiber made components. I want to say that lots of components are made in-house, so we were able to manage to reduce all the waste, the energy consumption, and also the transportation, since the company that provided us with the carbon fiber is located in Milan. For global warming non-fossil, the main impact is given by the design phase. We work mainly in our laboratory at our university, which is provided with solar panels. We also have an impact for 3D printers, but we are able to print so fast some components that meet our requirements, and we avoid all the wastes because they're so little and particular, so they perfectly meet our requirements. For mineral resource scarcity, we had to use copper for the wiring in the electrical components because of its conductive properties. But when it was possible, we used aluminum one to reduce the use of the copper. For the energy consumption, both renewable and non-renewable, As I said before, we mainly work in our university. So again, the electricity needed for our PC to work is given by our university, and obviously the electronics and software unit are the one who are using it the most. For the water consumption, again, the carbon fiber components are the one that are having the biggest impact, but we managed to study that using flex fiber in our overall cockpit was worse than using carbon fiber, especially in this parameter, because of its requirement of water for the production of flex fiber. For the marine eutrophication, the carbon fiber, we decided also to use less plies, and for these reasons, we add a little bit of flex fiber in our cockpit to use less plies of carbon, because we see that it was actually helpful for us to use just a little part and not doing the overall cockpit.
Okay, now take a look on the highlights of this year. We have an hydrogen energy system, and we reduce a lot the waste of the materials. For example, just to say something, when we cut plies, we take apart the filament that is a reed and make some components with carbon forged. Then we choose a lot of different material to make the correct components. At the same time, this year we design, in collaboration with our sponsor, a filament for the 3D printers. And so our propeller are designed, produced from us, from 0 to 1%, and also the material is made by us. And one of the most important things is that everything of the boat is made from us, to reduce also the transportation pollution. And we can go to the Agile.
Okay, so we are proud to say that Physis collaborates with Agile, which is a company that has the aim to take off 280 kilos of plastic litter, so our boat will be waste neutral. It's a B corporation funded in 2020 with the aim of taking out 1 million kilos of plastic litter from the ocean floor by the end of 2024. I used the Marine Shift 360 tool to calculate the impact of 280 kilos of plastic. I made an assumption of using 50% of the weight in LDPE, so low density polyethylene, and the half in polypropylene. And we can see that actually our boat will be waste neutral because of the offset of this this organization managed to do. They do not only make our boat waste neutral, but they also help local organization and local businesses, since the people that are catching the plastic from the ocean floor are local fishermen located in Italy, Greece, Indonesia, and Brazil. So they are getting paid to actually take off this plastic. So we are also helping some local businesses. So this is our catamaran. We are actually having hydrogen on our boat, which we think is the future of sustainable boating. We have a neutral waste, and also we actually are helping some organization and local businesses.
You have now 5 minutes for questions.
Hi guys, thank you for your presentation. I was wondering why you have chosen this plastic topic, since it's not, I think it's not so relevant considering your environmental impacts. Why have you focused on the collection of plastic instead of, for instance, water consumption or energy consumption? And if you are aware of what's the most relevant environmental aspects, environmental impacts of your boat?
Actually, for the use of the 3D printing technology, plastic is actually something that we have to consider. And we do not only want to put something in the future of sustainable boating, but also helping the world today, because we taking up the plastic of the ocean and not only helping the marine world, but they're also helping us because of the fishes that we're eating, so they will have less plastics in their body. So we're gonna have less plastic inside us. Actually, the main impact in our boat is the global warming fossil. So probably also taking off some plastic from the ocean also help this thing, because we want to have a future, an impact on our future.
Yes, so thank you very much for your presentation.
Thank you.
And your report was very comprehensive and very impressive. But I want to ask a question about your use of carbon fibre, because as you've said, it has a very high carbon impact, although not as high as, obviously water impact is higher for flax, but in terms of carbon, which is one of the main pollutants that we're having to deal with to tackle climate change, you moved, whereas some teams are moving away from carbon fibre, you've moved towards carbon fibre. And I'm just wondering, have you looked at, what difference that made to your carbon footprint, the increase in your use of carbon fibre, and also have you thought about ways to minimise the impact of that use of carbon fibre, for example, what to do at the end of life, or reusing it, recycling it, things like that?
Yeah. The last years we was here with a basal fiber cockpit, and I think that basal fiber is the best fiber for the LCA for a lot of reasons. This year we are here a little overweight, but the moment this boat is the lightweight boat, hybrid boat that ever been here in Monte Carlo. So this is the reason why we switched to carbon fiber. Moreover, I want to say that in the last months we had some problem with batteries, custom batteries that we realized, and if we bring it here, we will be under the limit. So this is a huge demonstration that we can make an hybrid boat in this way. As about your question, it's a race, it's a competition, so we would like to go fast, but at the same time we would like to consume less energy. So less weights, it's at the same time less energy consumption. It's okay? And
I want to add that maybe when we were hand laminating, if there are some filaments that were like, we realized that we were not using, we could like reuse it for like chops, or if there was like a waste part of our laminating pieces, we would use it for something else. And also our LCA, we decided to do a cradle to use, not a cradle to give or end of life.
Yeah, also at the same time, if we build a boat that maybe weighs like 320 of basal fiber, it's a beautiful fiber, but at the same time, it has a CO2 emission. If we make a boat that is it's less weight, at the same time, the energy consumption, the CO2 emission is less. So it's the reason why. And also in the graphics, you can see that the amount of CO2 emission is for the copy is very, very less. This is the reason why.
Thank you so much.
Grazie mille. And we continue with our other Italian team. We're welcoming UniBoat on stage.
Good afternoon, I'm Leonardo.
And I'm Federico.
We are representing now UniBoat, University of Bologna Argonauts team, and we are here to present our Eco Prize and Eco Conception, where we focused on sustainable engineering applied to our Futura catamaran. Firstly, we can talk about our Eco Conception philosophy. We can start with low impact materials. Our effort was to use recycled materials and from scraps from partners, and all the Futura components of our prototype, which led us to decrease environmental impact, promote a circular economy, and reducing waste. Futura also aims to compete, so attention must be paid to energy lasting power and energy efficiency, naturally. So we committed to reduce our load and optimize our propulsion system. That led us to enhance performance and minimize energy consumption. As you can see, we have the pictures of our new countertent propellers. But we don't want to spoil anything about later presentations. We made a LCA life cycle assessment study with the MS360, MarineShift 360 software. The goal was to evaluate the environmental impact of the Futura catamaran throughout its entire life cycle. We made this with the 6 main indicators calculated by the software, and we gained several insights that can be useful for enhance and improve ourselves in our project. Relevant information is that the 38.5 global warming potential of the entire project is caused by the trip from the trip of the team to Monaco, and that has led us to consider a more sustainable way to travel, and most of the team travel by train, so we think that is we think that is the first step to move to a green mobility and eco-friendly way to do this project. We want to maintain this mindset also for future years. And we can talk now about another further information, that is the use of scarce mineral resources. We analyzed that few components like fuel cells, batteries, and cabling contribute significantly to air exhaustion. And to deal with this, we try to recovery and manage better the use of these materials. We have taken some actions to improve ourselves in our project. like implementing recycling programs and precision manufacturing. This has led us to improve the efficiency of our sourcing. For example, we adopt new components of this year by to hold or previous mounting system.
So another important aspect of our eco conception philosophy is the life cycle management. In order to consider the end of life of our components, we wanted to go a step beyond what we can do with marine shift. We wanted to give a second life to the components also that are not actually mounted on the prototype. So we made a little database that was useful to consider the components that are not still on the boat or are not already on the boat, and consider our CO2 footprint about these components. We divided the components in reusable components and recyclable components in order to choose what will be the end of life of this component. We made a little bit of count about these components, so we are aware about what is the CO2 footprint of these components, and so we decided what to do with it. An example of what we did last year, maybe someone of you already know, we have the front fairing that become from a Formula student car that for rules need to made new cockpit every year. So after the season, this cockpit became a waste, and we decided to reuse the component and demonstrate that this performance component that has a evident problem with production process, so the impact of this production process can be reused and be useful and reliable on our prototype. Another example is our new bulkhead and pilot seat that came from part of the aerodynamical panel under the Formula student car. We collected, as for the other components that are not in the boat, we collected the data about the material, about for the laminate components, the laminate stack up, and also the CAD geometry. So through FEA analysis, we validated if it was suitable for our application or not. Thank you for listening to us, and we are ready for questions.
Thank you. It's a very nice presentation about the life cycle assessment. I know that you have tried to do it last year. Were you able to make some comparison in between last year and this year?
If we have a comparison between the last year boat and this year boat?
Yes, please.
It will be not be so suitable because we needed to remove the hydrogen system from our boat. But anyway, we can say that about energy efficiency, not the LCA, but about energy efficiency, you will see in the next presentation that we improved our efficiency through removing the emerged volumes and improving our transmission efficiency. Also, we made comparison between the weight of the previous boat and this boat, and this through the graphics of the drag of the hulls gave us the information about how many energy we are saving, being more lightweight than the previous year. And
another question, because by using recycled materials, you authorize yourself to use carbon fiber, or did you make the comparison in between having recycled carbon fiber compared to, for example, flax fiber or other natural fibers coming from, let's say, natural production?
Okay, we don't have a percentage, but we can tell that this approach is more sustainable because in our university we have a formula student team that need to change the components. So these components are really performing components that are overperforming in our boats. So I think it's more sustainable in our application.
Thank you.
Thank you for your presentation. I very much like your sort of life cycle circular economy thinking. I think that's a very powerful philosophy. I was going to ask a similar question about, you spoke a lot about all the insights you've gained from the life cycle assessment that you did, travel being one example and lots of other examples you gave. Have you looked at next year's design, or how much lower impact you think it could be because of the insights you've gained this year?
Maybe you can tell about the travel impact we can, how can we reduce the transportation pollution?
Yeah, we can do the transportation of the boat in a more efficient way. We came out here with 2 trucks and several cars, and much of the team traveled by train. We can organize ourselves better the next year. We can come here all by train and minimize the vehicle that come here, or use some vehicles that that go with also by electrical cars or something more sustainable.
Moreover, I would like to give another insight. We saw that electric and electronic components are really have a really big impact in our life cycle assessment. So I suppose that from the next year we are starting collaborating with a company that has a software like our database that insert the electronic and electronical components, and will help us to make the to analyze the disposal process of these components, and so we will insert it in the Marine Shift 360 LCA next year, and we will see what will be the impact of it.
Thank you.
Sorry, just a quick notice regarding to me, you were not so clear about the boundaries of your RCA. To me, it's not so important, your trip, because you are measuring the impact of the product of your boat, not the impact of the event. Otherwise, you should measure the impact of your stay here as well, of your food, of your, I don't know, where do you stay. So to me, you had to be more clear regarding what the boundaries you are considering. And that was not so precise. So I don't know if you have something to add, but just a notice.
Okay, we will do it, and thank for your suggestion, and we will handle with it next year. We never saw the data about it, so thank you for your insight.
Right, you thought we were done with Italian teams. That is not the case. Messina up on stage next.
Hello to everybody. I am here. My name is Giovanni. I'm presenting my team, Messina Energy Boat team. We are a team of 40 people that we are part of this project. We are researchers, PhD students, students of bachelor and master degree courses. Our goal is to promote the culture of the sea in the metropolitan area of Messina and the Strait area. So we are building this boat. We are taking we are part of this project in order to participate to the Eco Conception Prize. And so let's start. We used recycled aluminum for our frame that you can see there. It is very important because it's possible to recycle it, so we decided to use it for a green choice. We used also honeycomb panels for several structures in the next slides. Then we decided to optimize our steering with AM, so additive manufacturing. You can see there PETG printed of our maneuverability system. We also used AM for mechanical connection of frame and the hulls. Our goal was to reuse various components, for example, batteries and engine of the last year competition in order to reduce the impact of the CO2. We used Marine Shift 360 for making this type of analysis, and our goal is to reduce the environmental impact. So according our trials during the trials in the Strait of Messina, we took a lot of data by means of our transmission system and inserted like input in our software in order to calculate the impacts. So we used a cradle to grave approach. So processing raw materials, transporting, construction components to build our model to evaluate emissions. This project was our main goal is to digitalize our Strait of Messina. In fact, our boat is full of sensors for monitoring a lot of parameters that could be useful for other types of ships or other marine vehicles like autonomous underwater vehicles, aerial. So it is an example of vehicle-to-cloud ship or boat. We developed a digital architecture that can send data to our server and take a lot of data from sensors, for example, for the water monitoring and for the structural monitoring, so structural health monitoring. And our goal is to use all this data to train neural network, machine learning tools for optimizing the routes of ships and in order to reduce the impacts. So you can see from this slide our concept. We made a comparison between the boat of the last year and with this one boat. You can see the name Scirocco 48 was the last boat, was 1,600 kilograms of CO2 equivalent. So we reduced the impacts of nearly 600 kilograms of CO2. The most important factor according to this type of emission was the photovoltaic panels that are nearly 30% of our impact. Now, this year we decided to put nearly 650 watt of solar panels that could help us into the endurance race. You can see here some other parameters according to our analysis of our boat called the Guglielmino of this year. Some examples of additive manufacturing for realizing our structural components for connection of frame and the hulls. We made some FEM analysis according to a static point of view in order to prevent rupture, and our maneuverability system. So this is our frame. Is made up of two parts, where is put the battery on the left and the cockpit on the right. were honeycombs that are made up of a core and two skins to distribute flexural strains, as I said before. So then we developed our maneuverability system with a gear and two bearings in order to improve the gear ratio to guarantee to the pilot better sensitivity, accuracy, and the possibility to regulate the Dyneema ropes that grants to him the possibility to have better maneuverability. Everything is made by us. So you can see some trials that we made in our strait. You can see the Strait of Messina with our pilot. We emulated some trials with the boys, as you can see there. Okay. Thanks for the attention.
Thank you for sharing with us a comparison in between last year and this year, which is quite useful. Unfortunately, we do not have the same color and the same thing, so it was quite complex for us to compare. But in details, basically, we understood that you were able to reduce by 20% compared to last year.
Mm-hmm.
But could you give us some very big example about what was the decision you took this year compared to last year in order to have this impact?
Yes, the most important factor that reduced this number was reuse the batteries and the motor. This reduced a lot the impacts. And then we chose some other green choices for our transmission systems that helped to this.
Okay, and could you also explain how do you qualify that was recycled aluminium? Because it's quite complex to be sure that it is a real recycled aluminium, because we all know that aluminium is also very pollutant. Mm. So how do you qualify this quality of aluminium, please?
Because we made some reflections about the process of recyclability of the aluminium, and we stated that according a certain point of view, until a certain point, it could be recyclable. Okay. After that point, in a graph in our study, we stated that it was not convenient. So we made the internal our university study to discuss this, and we realized that could be a good choice for us.
Do we have other questions?
Thank you very much for your presentation. I think 1.63 to 1.05 is more than 20% reduction. But unless there's something else there that I'm not catching. But my question was about your report, or your LCA report, which is very well written, very clear, but it was weak in the area of interpretation. There wasn't much interpretation of the results. Mm-hmm. And so I'm giving an opportunity now for you to explain what you learnt from the life cycle assessment.
What we learned?
Yeah, from the life cycle, and what it might mean for future designs.
Yes. Yes, we learned that I think that the most important problem is always buying new components. So this is important in this field, but in other fields, okay? So we learned that try to reuse the old component is always the best choice, because is worth buying always new types of things. So we improved our components to adapt them to our boat, but our main choice wasn't to not buy other components. So we learned this, to reuse everything that we had last year and try to do this until it's possible.
Thank you.
Mm-hmm.
I have one remaining question. why do we have to select you to be the winner of the Eco Conception Prize?
Why we?
Yes.
Because we developed a very interesting digital architecture that could be useful not just for this type of boat, but for an ecosystem of marine vehicles that could be useful for the environment where we are going forward.
Then everything that you develop will be shared and given to the other? Then everything that you develop will be shared and given to the other as an open source platform?
Yes, because we can image, we can image a boat with an autonomous drive that goes everywhere to make tests for the water, for the air, for the pollution of the ships in the port, and send this data to other marine vehicles that can charge, because they are electric, between them, and make a sustainable environment for taking data, because we saw that at January there was the new guidelines of the European Union for monitoring emissions in ports that ships are mandatory to monitor, and these systems could be useful for checking possible violations in emissions into coastal areas of European Union states and other countries.
Thank you. Thank you very much.
I hope you're not tired of our lovely Italian colleagues, because we're inviting University of Genoa up on stage.
Good afternoon, everybody. He is Nicolò, head of Naval Marine team of Elettra, and I'm Cristiano of Electronic team. And we are here to speak about Eco Conception Prize of our project. This is not my slide. Okay. We started with a goal, and the goal is understanding how to reduce the environmental impact of each of our component of our boat. And we did this with a philosophy. And maybe the philosophy is building a green future, of course, because maybe if it's the reason why we are here now, everybody. And so, to do this, we carried on with different plans, for example. We call this one, that one, plan A, plan B, plan C, but the plan A is the plan that we used the previous year, the first year that we participated here. The plan B is just it's the same as plan A with a modify that it's a new kind of batteries with more efficiency. And finally, we had a plan C, that it's the plan B, but with a new kind of inverter that increased our instantaneous potential power.
Thank you, Cristiano. And now let's talk about the scope of our study. The scope is to assess our environmental impact, and by analyzing the data, we identified some areas where we can improve, also this year, but also for the following year. And so this study provides new approaches to become more sustainable. To do this, we use Marine Shift, which is a tool which permits us to analyzing some impact categories, like example, water consumption, global working potential, mineral resource quantity. And now we also have the possibility to see the different areas of the ship. For example, in the image, it's reported the production, the use, and the end of life. We don't consider the end of life because at the moment we are not sure when we will dismiss this ship, because most of the parts we think we will reuse in the following year, so it's impossible now to make a correct provision. And then now let's talk about our philosophy. we use a data-driven approach to project the boat. Just make some example. The propeller, we use PLA instead of nylon because PLA is biodegradable. Another example, the cockpit. We decided to substitute the carbon fiber cockpit with the new flex fiber cockpit. The flex fiber cockpit is almost carbon neutral because the resin is carbon positive, but the flex fiber is carbon negative. So it balances in a very good way the impact. So it's not just about building a boat, but it's like shaping a green future.
Okay, here we have our first graphic of Plan A. In particular, we have a graphic about total GWP, that it's global warming potential, regard to fossil. I didn't say that I want to compare Plan A, Plan B, and Plan C because one of the most important things that we did is that we carry on all of this in parallel, and so to find the best solution for us. So here on the left we have the production, so kilograms CO2 equivalent regard to production. So this means this quantity for each component that we have in this legend. And about the use is the CO2 kilogram CO2 equivalent of the materials that we used the previous year and this year. And so we can see that we reuse and so we recycled a lot of materials. Here we have some number, and for example, we will see that, for example, GWP fossil, just for simplicity, is 4.8 kilograms CO2 equivalent. Plan B is very similar about GWP fossil. Other numbers. And also for Plan C. But maybe it could looks like a contradiction, but actually in this way with the Plan C that we are currently using, we increased our efficiency and also we increased our instantaneous power. And so this is what we used.
Okay, now let's talk about the comparison between all these our plan with last year boat. So as you can see, for fossil, for non-fossil, and mineral resource quantity, the global consumption is about just slightly the same. The main difference is from production and to use. So this year we were able to increase the use area and slightly reduce the production area. This is also for energy consumption is slightly different for renewable and for water consumption, but the value are very similar. And now, just to make some conclusion, we conducted a detailed LCA study to assess the environmental footprint. Various improvements have been presented to enhance the sustainability and the efficiency, just like the propeller or the new flex fiber cockpit. And then a detailed analysis for each impact category have been conducted, and the comparison between the plans footprint against this year and the last year was presented. So, thank you for hearing.
Thank you so much for the presentation, and it's true that, for my opinion, sorry, it's not the best presentation I have seen, but that was exactly the kind of subject that I want to highlight. So very congratulations for that, because that's exactly the way I think we all need to think about designing the future with a life cycle analyzing approach, and helping us to decide about what will be the best design in between the building, the use, and the recycling. So I have to congratulate you for that. Could you please maybe answer the difference between the plan B and plan C? We understood that there is a huge difference about efficiency. This difference is coming due to the weight, or is it coming from which, where it's coming from, this difference of use? And where is the trade-off in between, let's say we can take 10 kilos if we are 5% more efficient because we were considering the bird during this amount of hours, like giving us big numbers about helping you to take this decision in between the plan B and the plan C.
Okay. Plan B use a kind of custom batteries of lithium, in particular nickel, manganese, and nickel, so NMC. But this is not important for your question. The question, actually, we reduced the weight of 20 kilograms, and also we increased the efficiency. But and we can see this because before, with the plan A, we had 6.5 kilowatt hour of energy, and with these new kind of batteries, we have 9.6 kilowatt hour of energy, reducing the weight of 20 kilos. And so this is the good thing of this change of plan.
Yeah, but the 20 kilo are representing how much of efficiency? What is the percentage of efficiency you save by 20% weight saving?
Yeah. Maybe we used CFD analysis to estimate, and we also see here in Monaco the difference. The difference is about 11–12%. So we thought it's a good amount of efficiency to make this change.
Your answer is 20 kilo is around 11% of efficiency.
Yeah, it's too bit complicated to estimate properly, because in CFD analysis we had the problem to estimate the correct center of gravity.
Sure.
And in general we use the same hull, but they're very heavy, so it's complicated to estimate properly. And so maybe after these races we could be more precise.
Thank you.
I just wanted to underline that the end of life is so important in order to measure also the impact of the materials. For instance, the flex, you mentioned it's carbon negative, but is it recyclable? Because if it's not recyclable, it's not carbon negative. So you have to consider the end of life of trying to do some hypothesis on that. So the best option can be, I don't know, that all the materials will be recyclable, or I don't know, but to do a complete presentation, the end of life, it's fundamental.
We know that the fiber is recyclable, but also the resin. So we were so happy by introducing the new cockpit, because we know it's recyclable, and the old one is also with us just as a spare parts, because this is very light. So we are not sure that this cockpit will probably be reused for many years, because it's very lighter. So we don't consider the carbon fiber in the end of life, because it's still in the team.
Perhaps we can start thinking about projecting for dismantling from the beginning. It can help also to understand the end of life of our project.
Yeah, this is our second year, so probably we didn't decide to make this, but in the next year we will consider this opportunity.
Grazie mille. And our next team will be WannSea. Willkommen auf der Bühne. WannSea is on the way. I see them.
Hi, I'm Andreas, and just like last year, I was sitting there and watching all the tech talks and trying to figure out how to make our boat more eco-friendly. And just this question I'm trying to answer today with Felix for you. So, we had some regarding the design decisions. We always try to make them more eco-friendly and more sustainable while saving energy and making this process happening. To paint you a picture, what we were able to work with. We last year had a budget of approximately 60,000 euros, which was cut in half this year. And also this year we had a battery saving, not saving, I'm sorry. Our battery budget was around 15,000, and that made our total budget around 15,000 euros and cash as well. So with that, we not just had last year 2 electric motors, which were overpowered by the Mediterranean heat, and that is why we launched our own design competition. In this, we finalized one part which had a direct drive, and the solution is completely in the gondola, encased, didn't need any cooling because of the surrounding water which is flowing by, and the different part is trying to use the complete cycle, which you may see here as counter-rotating propellers. And yeah, so right now we are using, unfortunately, none of these, because we are not completely through with the technical inspection. But if so, we are probably using in this year's Monaco Energy Boat Challenge the direct drive, because it has less moving parts and will be more sustainable. Yeah, might say that. Yes. So to this year's Eco Conception, we try to reduce all parts necessary. That's also the main focus of the direct drive, and reuse all parts of the last year's competition, which we're able to reuse. And exactly the problems which occurred from this, now Felix, our head of design and construction, is trying to answer you.
All right. So let's talk about our material of choice. So as Andreas already told you, we have reused lots of material and compartments from last year. So the big change this year were only in our longitudinal struts that keep the boat together. And unfortunately, we had to get rid of our bamboo, which was quite the signature of our boat last year, and replaced it with aluminum to gain a weight reduction of about 8 kilograms, as we had to get so light this year. And so we also looked into into some alternatives. We tried to get the weight reduction and still be sustainable. So we looked into basalt fiber, which, as you can see in the graph, is almost concerning the global warming possible global warming potential as good as the bamboo struts. However, it is really expensive to get those, and we were not able to afford those. And in orange here, you can see the global warming potential of the aluminum struts that we are using today. It is the percentage. It is shown in a percentage, and yeah, since it has such a negative impact in global warming potential, we want to make sure that we reuse these components as much as possible in the next coming years. Now for some numbers. We consider every boat that we build each year as one boat, and that has a lifetime of 1 year. And so therefore, in the use phase, we don't see high numbers, and in the production phase, most of the negative environmental impacts occur. And let's take a focus on the fossil global warming potential, which is mostly driven by our new change in the longitudinal struts. And makes it really high. And since we use lots of wood this year, again, we are negative in the non-fossil global warming potential. And due to the time constraint, I will not go further into the other details. Okay, so as I said, almost all global warming potential was produced during production phase and practically none during use phase. And as I also said, we want to reuse those aluminum struts for a long time, which we probably achieve because we have made almost non-modifications to it, and we will probably keep it for several years from now. And as you can see in the total breakdown on the bottom right here, those changes make almost half of the global warming potential of our whole boat. So this is due to reusing so much of the material that we had last year, and because of using so many natural components like wood and basalt fiber, not basalt fiber, flux fiber. And yeah, that is already it. And I'm open for questions.
Thank you. I hope the scope of the use will increase when we will have the technical inspection, so you can use the boat.
Yes, we are almost through it. When I came up, we only needed to weight the boat, so it is clear, I believe.
Cool. Maybe a question. Why do we have to vote for you as an Eco Conception Prize? Compared to the other ones that you have seen in front of you?
I would say because we try to use the most natural components of most teams, and try to really bring the focus on the construction of the whole boat to reuse as much, and also choose the right components, and mostly focus on natural components, also because of the waste that, for example, composites produce in the sea. Like if we use wood, there's also less microplastic around, and so this is also a benefit in terms of pollution and not only global warming potential.
And if we compare to your predecessor, we have seen that by 20 kilos they were able to save 11% of efficiency. So we have seen on your this decision about using aluminium in the place of bamboo, you are saving 8 kilos. how many efficiency do you save, and that efficiency was compensated this amount of emission with aluminium.
What do you mean with efficiency of the boat?
When you save 8 kilo on your boat, you are gaining in efficiency. How many efficiency did you won? And due to this efficiency, was it able to compensate the over emission of the aluminium?
I think I still don't understand the question correct.
The main reason we choose aluminium was not because of efficiency constraints, but of weight constraints in the overall. We wanted to use bamboo still, but we're not able to because we are already scraping at the uppermost limit of the overall weight. Okay.
Thank you very much for your presentation. And when I was looking at your report, I saw you did have the lowest carbon footprint of any of the designs, and I think you've explained well why that is. Obviously, it's not the only thing we take into account, but I think it's because you had so high a level of reuse from previous years. But I'd just like to ask a bit more about the bamboo and aluminium. Was there any other options you looked at for reducing the weight so you could retain the bamboo struts?
We have also built a new battery electronics component that is smaller, so this would fit into the reduction category of just reducing the material used. And we have almost used newly bought materials. We used, since it is so small, the battery compartment, we could use like materials we had still left from last year. And therefore, we didn't have to buy any new, or almost no new components for that part.
But did you look at any other options for lightweighting apart from the battery?
We have done research in it for reducing the weight of the wooden constructions. But we have not applied them because we still have the old cockpit, for example, and some of the old compartments. So only when we think we have to build a new cockpit, we would apply those principles like cutting the wood thinner and researching more firmly constructed compartments out of less wood and material.
Thank you.
And for our last Eco Conception team, we will welcome the Portuguese Técnico, por favor, on stage.
Good afternoon, everyone. My name is Miguel. I'm the current team manager for the Technico Solar Boat team, and today I'll be showcasing the eco-conception philosophy of our newest energy prototype, the São Miguel's Route 2, and how it adapts to our current game plan of the team. So Technico Solar Boat was founded in 2015 for a group of students as an idea to bring a little bit of the nautical industry to our university through building sustainable, through constructing sustainable energy-powered vessels to compete in international competitions where we would be representing Portugal. We started with solar energy with our first vessel constructed in 2017, and we embraced hydrogen as an alternative energy source in 2021, marking this year as our fourth participation in the energy class, plus one online. Before diving into our newest prototype, I would like to start to give a little bit of context into what São Miguel 01, our first energy-powered energy vessel, powered by hydrogen really was. São Miguel was constructed on 3 premises: reduce, reuse, recycle. An idea to construct a prototype that could compete along with our solar-powered vessels, our São Rafael series, but would be even more sustainable and would embrace the green mobility that is at the team's core. So we wanted to build a prototype that was more sustainable. So we didn't want to construct an entire new mold. We used the mold from a former student team from our university. We didn't want to use carbon fiber, so we used flax fiber that was more sustainable. We didn't want to use petroleum-based resin, so we used a bio-based resin, and so on. The idea was there to build a sustainable a more sustainable vessel that could represent Portugal internationally. Unfortunately, São Miguel 01 wasn't as perfect as we imagined. We had some problems with the molds at first. The molds were not ours, we had to reuse them. So we spent a lot of time in the mold treatment. We used a lot of resources in the mold production to get a nice finish for our final cockpit. And the boat production itself also took a lot of time and a lot of care to get quality that could, again, compete in Monaco and represent Portugal at the highest level. This worsened when we started working on the vessel itself. The cockpit of a formal student car is not suited for sea. We had problems with accessibility. We had problems with reliability on the vessel. And we realized that São Miguel 01 wasn't as perfect as we initially imagined. It was sustainable, it worked, it ran 3 years. But we knew that we wanted more. We are a competitive team at our heart. In our core, we represent our sponsors, represent our nation, and we wanted to give more to the energy class. So we started working on São Miguel 02 at the start of this year. We wanted to build a boat that would be lighter, faster, more efficient. And this was a challenge, not just because we were constructing an entire new prototype, but because we were trying to get an hydrogen-powered vessel that would be competitive. For those who work with hydrogen know that that's a challenge. In acceleration, in efficiency, in all of the problems that hydrogen has, even though it's an incredible energy source that we believe it's the future, and we have spent this past 3 years, not these 3, but 5 years, since 2019, we started working in R&D in development of hydrogen technology. We know that it has potential to become an incredible future for sustainable yachting. But it's a challenge to get a boat in the energy class that will be competitive, and we wanted that. So it was a challenge to that, and also to manage resources with our solar boats that will also be competing this year. So we knew that we had to, unfortunately, abandon some of the ideas that São Miguel 01 brought. We had to go back a little bit. We had to go a little bit back and, unfortunately, abandon the flex fiber idea, and we had to go back to the carbon fiber that we have been working in our solar-powered vessels since 2017. Through this year, our design and composites department started working with different kinds of laminations to get a cockpit and enclosures for our systems that could produce a vessel with quality and at its core to be competitive. We work with prep-reg, infusion, and wet wave laminations. We used male and female molds for the cockpit, and we used, again, carbon fiber, Kevlar, and glass fiber materials to get our boat working. It was not perfect, but it worked. And the boat was in water just a month ago for our first water testings. So now, to get a little bit more into the eco conception part, I will start by giving a scope assessment. We work with 4 subcategories. We analyze throughout our report in the Marine Shift software the elementary flows, where we analyzed the extraction of the raw materials that we used, the distribution of those raw materials to our production, to the production part, where we work with them, the product flows themselves, where we work with the products to give the final material, and finally, the usage of the boat itself and how we would adapt to Monaco's and the boat's final conditions. And finally, some of our results. This is the CO2 emissions that we obtained. We estimated the CO2 emissions to be around 2,500 kilograms, with most parts to that attributed to the cockpit production. After that, our 2 electric propulsion columns from Turkey, and finally, our battery. I didn't mention, but we also had to abandon another idea that São Miguel Terrum had. We couldn't simply have a hydrogen-powered boat to be competitive. It simply wouldn't be possible. So we adapt the idea to construct a more hybrid vessel, a boat that would have both fuel cell, hydrogen, and also a battery that could give us, that could fill the gaps that hydrogen simply couldn't give us to compete here in Monaco. And finally, the energy the energy consumption for the production of the vessel themselves. We estimate it to be around 40,000 joules, with most of that attributed once again to the cockpits, after that the propulsion columns, and then the battery. These are some scary results. At the first glance, it might seem that the boat is worse in a lot of ways. It is indeed an increase in 20 to 30% for our last vessel, São Miguel's One. However, it's important to note that we reused most, if not all, of the systems for our hydrogen part of the vessel, our fuel cell, our humidifier, most of the pumps for the recirculation of hydrogen, and for the water pumps, our blower. Most of that was reused for our vessel. We reuse a lot of materials in our construction. Our design and composites department has been dedicated to a zero-waste policy to protect our future, in a way. So these results might seem scary at first, but we believe that this might or must be the way to giving us, again, a vessel that it's not just a vessel that's competing here at Monaco. It's a vessel that we will be using for studying new technologies. At its core, Technico Solar Boat, again, wants to develop new technologies. We want to maximize what we do, and we simply couldn't do that with a prototype that was just heavier, less efficient, and in theory it might be good, but in practice it simply is not. So São Miguel's Rodu was born in that way, and we believe that it's the right way. Thank you.
I'll ask first question, maybe. This is maybe one Jeremy's going to ask, but why do you think you should be winning the Eco Conception Prize?
Again, as I mentioned, São Miguel's Route 2 for us is not just a new prototype. It's a challenge to bring competitiveness, efficiency to a very competitive class here at Monaco, and to manage resources that could, again, bring this equilibrium, let's say, in a way. And again, the boat, it's a test bench for us to develop new technologies also. In the hydrogen, we presented an innovation prize in the hydrogen part yesterday, but also in the electrical and the mechanical parts. And even though we can do all that we imagined to the prototype because lack of resources, we do believe that São Miguel's Route 2 is a step in the right way for even more ambitious projects in the future. We want to keep working with hydrogen, we really do. We want to keep innovating in composites, in electrical, mechanical parts, and we want to maximize that to give a future to yachting. And that's on the core of the project. That's why I believe that we should really win the Eco Conception Prize.
Thank you. I like the word about we want many things, but I want also you to be an engineer and give the numbers in front of the wish, you know. So you say that you were obliged to go back to carbon fiber because you have some flax fibers that was, I understood, a bit too heavy. Could you give us the numbers? Why was it too heavy? How many weight did you win? And what was the impact on the CO2 emission on your boat? You know, in this Eco Conception Prize, in the life cycle analysis, the idea is to have the tool to help us to take the good decision in order to have a better future.
Yes.
It's not only just, I would say, we all want to have a better future here. But why are we driving then electric while the electric is polluting a lot? Because there is an impact. And we know when this electric is becoming better compared to fossil fuel. So if you take the decision, we want to have the argument explaining why you took this decision. We need this information in order to be able to give you the correct graduation.
Yes. I completely agree. We try to be as transparent and honest in our report as possible. And like we mentioned there, and I can mention here, São Miguel 02 has an increase of around 20 to 30% in both energy and CO2 emissions. Again, that's scary, but that's natural considering that carbon fiber is petroleum-based, as the resin that we used. That, taking into account now the part of the flax fiber, it was heavier because it absorbed much more resin than we imagined at first. That resulted in a much heavier cockpit, in a much heavier systems enclosure, and we estimate that the cockpit for this vessel weighs 5 kilograms, if that much, and the last prototype weighed 15 to 20 kilograms. That's the numbers we are working with. Flax fiber, it's good on paper, but for us, we realized that it absorbs much more resin, and let's take into account also the fact that bioresin, even though it's bio-based, it has a very similar production process to a simple epoxy resin. So it's not as bio as it might look at first. As much as flax fiber is not as efficient or sustainable as it might look, simply because it absorbs more resin. It gives a less efficient prototype, then on the course of its use, it might just produce more emissions. Those were some of...
And then could you also share some ideas about hydrogen? Because you are one of the only team taking the risk of having some hydrogen. So that's a very good step. Very congratulations for that. But what are the impact in CO2 emission in the overall life cycle analysis? This might give you a good chance about having a better grant from the jury tonight. If you can explain what is the impact of hydrogen compared to a battery, for example.
So let's say, for instance, on our vessel, São Miguel 02, we have more or less half of the power from the fuel cell and the other half from the battery. We can, with some very rough results, we think that the battery has, let's say, again, it's very rough results, but battery, as you said, as I mentioned on the reports, and as I mentioned here on the presentation, it was one of the highest consumptions of the CO2 emissions and of the energy consumption. If we consider that if we use the total battery just for the boat, we could imagine that those numbers would double or even triple. So this just to give an insight on what hydrogen can really give to the yachting industry.
So thank you very much, everyone. These were the presentations and the finalists for the Eco Conception Prize. But before moving forward for the Prince Albert Foundation Award, I would like to invite Craig Simmons as head of section for the Eco Conception Prize to summarize and share some insights with us regarding the finalist presentations. So Simon, please.
Thank you. Well, firstly, I'd like to thank all the teams for being here after a busy day on the water and a not uneventful day on the water. So thank you very much for being here. And also, I'd like to say the Eco Conception Prize attracted more entries than any other of the prizes. And I think that's a very positive thing because it shows that all the teams have an interest in sustainability and looking at more sustainable design solutions. And we've seen that here today. What we did was give all the teams the same instructions. We gave them access to Marine Shift 360. And you're in good company because that's currently being used by 2 America's Cup teams. So you're using the same tools as those professional teams use. And I know that's challenging for you, but I think it's important that we do stretch your design skills and your sustainability skills and expertise by giving you the tools that the professionals use. We gave everyone access to the same software, we gave everyone the same instructions, we gave you the same reporting templates to use, with the aim of making our job as judges easier because we could compare things more like for like. But I have to say, it's not a very easy job because when we did the shortlisting, I can tell you that only a handful of points separated the teams in the top 6. So the quality of the submissions was very high, much higher than last year. So thank you everyone for your efforts. So the presentations this evening did make a difference, will make a difference, I'm sure, to the way the judges score. And you did get some challenging questions, and I think that's important because we're really trying to differentiate between teams which are very close in the way they scored. When we looked at the reports, some were strong in some areas, some were weaker in others, but overall they ended up being very similar. So thank you very much. You've given us a difficult job, and now we have to go and all the judges are scoring this category. So we'll be doing that now, but thank you very much for your time.
Super. Thank you, Mr. Simmons. We are going to move on to 2 entries now for the Prince Albert II of Monaco Foundation of Sustainable Yachting Technology Award. This award is dedicated to recognizing and supporting outstanding initiatives presented by universities or research institutes during the Monaco Energy Boat Challenge. The winning organization will receive a grant of 25,000 euros to further develop and implement their solutions. We're welcoming now online the Alexandria University from Egypt. So welcome, Alexandria University. It is perfect.
An overview for what we will talk about today. We will have introduction and HHO generators, practical experiment, and why we use HHO gas. Actually, we are concerned in producing and generating HHO gas and use it as a secondary fuel in the internal combustion engine, gasoline fuel. So, in the fast introduction about it, 1 liter of water can have 1,235 liters of hydrogen, 622 liters of oxygen. With summation it, we have 1,857 liters of HHO gas. This gas, we call it the next generation of hydrogen because it's an hydrogen attached and bounded chemically with oxygen. And we will know in the next slides what the reduction in emission, what will this gas do with the fuel consumption, and this gas hydrogen, and it's have a lot of benefits in using it in internal combustion engine. Also, this gas is another phase. It's another gaseous phase of water in normal condition, in normal temperature and normal pressure. Okay, HHO generators. We have two prototypes to generate this gas. First, BWM electrolyzer, pulse width modulation, and voltage potential electrolyzer. First, we have BWM electrolyzer. We use this prototype. Have current 3.5 ampere and voltage is 13.7 volt. Our power is 48. Don't forget it. 48 watt, and the production was 18 liters per hour. In this device, we use BWM circuit. We enhanced the power consumption, electric power consumption in this circuit, and increase the amount of gas production in this prototype. Okay, in this prototype, we interest and concerned in reducing the gap between the anode and the cathode. That lead us to generate the HHO gas. The more the gap between anode and the cathode is increased, more the chance for hydrogen and oxygen to separate. We didn't want to separate them. We need them in HHO gas. The another thing in our design, reducing the gap between anode and the cathode, reducing the amount of power consumption. Because the current in water is run away and convert in thermal temperature, increasing the temperature of water, the temperature, and there is a steam produced in this electrolyzer. So we didn't like that. We reduce the current, we reduce the gap, and reduce the current, and reduce the steam which can produce in water if the water go to the boiling temperature. The next electrolyzer was voltage potential electrolyzer. This electrolyzer, we concerned it in two things: the high voltage in the cell and the high frequency in our cell. This prototype, it's not completed. We are working on it right now, but the research papers which make it have current with 1 ampere and voltage was with 12 volt, and the power was with 12 watt. The production here is very, very high. The production is 360 liters per hour. This is a graph for our prototype. We have here anode and cathode. As you know, the anode and the cathode can work as a capacitor in any electrolyzer. It's like a capacitor. So in our circuit, we concerned it to increase the voltage in this cell. So we have inductor. We must increase the volt to up to 1,200 volts. So we make the capacitance resistance equaling the inductance resistance. There we have the resonance in the circuit. We achieve the resonance in the circuit. The next thing we have to calculate the natural frequency of the material of our cathode and anode to prevent the high frequency, to make this to reach the natural frequency of the cell and our cell failure. So we know the natural frequency of our cell, but we induce natural electric frequency to our cell away from the natural frequency of it to prevent the resonance in material and the dynamic to prevent the dynamic resonance in our cell and to make our cell not to fail. We make to make our natural frequency the natural frequency of anode and the cathode equaling each other. We make a slot in the cathode. As you see here, there is a slot to make the natural frequency of inner tube and the outer tube are the same. Practical experiments. Actually, we don't have the financial aid to make practical experiments, but we take these practical experiments from research paper, well documented, and what we will show you right now. This is a schematic for gasoline car motor. As you see, there is we have an input here, the airflow, and the fuel is an input. We add our fuel cell connected to the battery of the car, and there is an exhaust gas from the engine as an output. The exhaust gas is attached to oxygen sensor, which calculate the amount of oxygen not burned, and we have the mass airflow sensor and the main absolute pressure sensor go to the control unit, electric control unit, to control the amount of fuel which will be injected in the engine. Actually, the airflow rate, the air fuel ratio here is the same before using the HHO gas and after using the HHO gas. Hyundai Sonata, our first experiment was on Hyundai Sonata 2000 cc. They use in these experiments current with 15 ampere and volt with 12 volt. The power was so high, 180 watt, and the production was so low, 6.2 liter per hour. Our power was 48 watt and the production was 18 liter per hour. But what we want from this experiment, we want the emission reduction and the fuel consumption reduction. The CO2 reduction inside the city was 31.4%, and the combined inside and outside the city was 32.9%. The fuel consumption inside the city was reduction with 30.6%, and outside and inside the city combined 32.8% in reduction of fuel consumption and CO2 emission. There is also an increase in mechanical efficiency, thermal and brake power efficiency, as we see 24%, 47, and 22 respectively. Second experiment here, we have Skoda Felicia 1300 cc. In this experiment, they use a volt 12 volt, and the production was same of our production, 18 liter per hour. But they didn't talk about the circuit, the ampere, and they didn't use BWM circuit. So we assumed that the power was so high and the current in this experiment was so high because this experiment was kindly old before using the BWM circuit. Okay, there is a thermal efficiency increased by 10%, and the brake specific fuel consumption decreased by 33%. And monoxide decreased by 18%. NOx and nitrogen oxides increased by 15%, and finally hydrocarbons increased by 14% in this experiment. Why we use HHO gas? The advantage of using HHO gas, as we see, using HHO gas gave us a complete burn in the internal combustion engine in the combustion chamber. So it's enhanced fuel consumption, enhanced fuel efficiency, and as we see, we have reduction in emissions, increasing the engine performance because as we see, the increasing in thermal, mechanical, and brake power efficiency. Finally, ease of installation and integration. It's easy to install the HHO gas with the air filter go directly to the engine. There is no problem in using it and install it into the engine. Lowering the operational cost because it's lowering the fuel consumption, eco-friendly alternative because we use it and produce it from green energy and electricity. Finally, safety and reliability because we produce it and it's go to engine direct. Need to be stored, and this reducing the risk of storage which can be harmful in the future. It can be harmful to the environment if there is an ignition can be. Finally, remember that green hydrogen for green future. The next future is the green age of hydrogen. Green age. Thank you so much.
Thank you so much, Alexandria University. Now you will have 5 minutes to answer the questions of the international jury. Thank you.
Thank you for your presentation. That very nice, but I am missing some numbers. I want to see some numbers about the energy you need to produce the HHO. I want to see the efficiency that I increase. I want to see the total efficiency in order to be able to calculate that.
The increase in engine?
Yeah, I understood that, but how much do I consume to produce?
Okay, first work from 0 to 1000 cc, the consumption of HHO gas will be between 0.3 to 0.5 liter per minute.
Okay, thank you.
Maybe I could follow up on one of those questions. So thank you for your presentation. I think the question that you didn't answer from Jeremy was the production of HHO gas, the energy used to produce it, as opposed to the energy used to produce hydrogen gas. I can see the advantages of HHO gas in use, but what I don't know was how much energy it took to produce it as opposed to hydrogen gas.
As we see in our prototype, we consume 48 watt to produce 18 liter per hour. What's mean there is 300 milliliters per minute. We achieved it in the car. The same car in the practical experiment, the second experiment, had the same reduction of our prototype. As we see, the cc of the car, the cubic centimeter cubic of the car, has from 0 to 1000 you have to use between 0.3 to 0.5 liter per minute. That's what we have achieved in our prototype and what we see in the experiment. We see the reduction in fuel consumption and the reduction in monoxide, carbon, reduction in hydrocarbon, and the reduction in all emission only.
Yeah, so I understand that. Maybe I'm misunderstanding, but to produce the hydrogen gas, which is your alternative to HHO gas, how much energy does it take to produce the hydrogen? And then how much energy does it take to produce it in the first place? I understand it's more efficient when you use it.
Okay. As we know, to produce 1 kilogram of hydrogen, we have to produce it with 50 kilowatt hour, which the same kilogram can convert it to electricity by 33 kilowatt hour. I know I understand your question, but when we see the efficiency of fuel cell, hydrogen fuel cell, it's very low because the production of steam is so high. So we have between 80 to 90% of the production gas is steam because high ampere is there, and this will make the water boiling and generate steam. There is just we have used 10% of the gas is hydrogen. That's what we prevent in our cell. That's what we prevent in our fuel cell. We have reduced the ampere as we can, producing another gas, and we can use it in the internal combustion engine easily, gasoline cars, to reduce the fuel consumption as we see.
Yeah, thank you.
I find it interesting that you are proposing not only, let's say, a purely electric or hydrogen solution, but something that is reducing. My question is, what is the impact of retrofitting an existing yacht with your technology? I mean, there is the engine, there is the storage of this gas, there is the distribution, the control, and the refurnishing of it. So it is not something that comes for free.
Okay. This gas, we have an advantage in this gas. We don't storage it, and this is an disadvantage. But the advantage there, we can produce this gas and directly go to the engine, as I said, to be burned in the engine. The another disadvantage of this gas, the power consumption. To produce even the hydrogen, we need a high power consumption. We reduced it here in HHO gas, and in the future we aim to reduce it more and more. This is the harm, the more disadvantage of this gas. The another thing what it's a big advantage of this gas. The auto ignition of it is 570 Celsius, which can make us, if there is more, we produce it in the car more than what we need, we can release it in the air. without any harmful thing to the environment.
Thank you. Maybe the last question that might be useful for all of us. If you won these awards of the Prince Albert Foundation with this 25,000 euro, how it will help you, what you will do with this amount of money, and if you do not have this money, what will be the future of your project?
You win in this competition today. That will inspire us and motivate us to complete our way and continue in our way to complete another device which I talk about, which have a big production of hydrogen, of HHO gas, and a low consumption of power. That's what we want in the future, and we want in the future to use HHO gas as a primary fuel, not as a secondary fuel, to reduce, we can change the world right now, immediately. We can change it steadily, step by step. So by 2050, we have zero emission, zero using of fossil fuel, the harmful fuel in the future. So that's what we aim to complete our project, to complete our research, to complete our goal, to make something and leave something to the humanity to work on, and we will be very happy to win this competition.
Thank you.
Thank you.
Thank you very much, Alexandria University and the representatives for their presentation. Take care and see you in Monaco, hopefully in the future. We will end our session here with one more representative for this prize, that is the Università di Bologna, up on stage for that presentation. Hello everyone. Hello everyone. I'm Jacopo Roncuzzi, the team leader of the University of Bologna Argonauts team. I'm glad to be here, invited by the Prince Albert II Foundation, and I'm here to present you Competer, the first electric outboard motor with counter-rotating and tractor propellers. How it's made? We have an electric motor in head that moves two counter-rotating and tractor propellers that, with the specific aim to reduce energy consumption during its use phase by up to 15%. We aim also to reduce the global life cycle by choosing recycled materials such as aluminum and low carbon footprint such as flax fiber. One of our innovations is to introduce the one-to-one transmission in the ogive that limits the RPMs of the transmission, and we did it in order and with the special design of the ogive that limits the frontal section area in order to reduce the drag. Another innovation is the special shape of the stem, which can allow the height of the axis to be regulated, of the axis of the propellers to be regulated during the navigation. This allows to sail also in shallow waters. Another innovation is the simple and flexible design. For example, we separated the structural part from the hydrodynamic part, introducing some hydrodynamic covers on the structural part that allowed us to reduce the cost of production. We found some implication of this product. Of course, the catamaran application and also the foiling application, because the clean water flow that invests the propeller is enhanced in these situations?
So yes, as you can see here, we put some values of the electric outboard motors value market. These values are wrong. We didn't have enough time to gather enough information since it is a quite niche sector, but I can tell you that we made rapid analysis, and the value for the market in 2023 was of around $120 million US dollars, and the expected compound annual growth rate for 2027, which is the final year of our potential collaboration, is of around 8.6%, meaning that by this date we can estimate that the market value will be of around 170 million US dollars. Why I say this to you? Because we think that this product is marketable, and this is the case because we are able to satisfy various key drivers of the market, of the bullish market trend. So first of all, environmental regulations, especially at EU level, eco-conscious consumer demand increase, technological advancements, but most importantly, the superior sailing experience ensured by our solution. Meaning that with our solution, we are able to ensure a decrease in noise in the use phase. Secondly, a reduce in vibration for the electric powertrain. And then lastly, there's no need of fuel management, meaning that you can use it whenever you want and you don't need to recharge the fuel. I leave the floor to Professor Cavina.
Okay, so let's see what we have done up to now. The computer project started in September 2023 with the concept and state-of-the-art analysis corresponding to TRL number 1. That was the main idea. As we all know, inboard counter-rotating tractor propellers exist in the market. Volvo Penta IPS is one of the main examples. But our solution, extends. Sorry about that. What happened? Oh. Okay, maybe. Our solution extends this concept to outboard motors, thus allowing to bring this higher efficiency due to the specific configuration also to smaller and leisure boats. This is the main point, I think. In December 2023, once we thought that this concept was valid, we started the actual design and virtual prototyping phase. So we defined simulation environments both for the structural parts and for the fluid dynamic parts. So both structural simulations and fluid dynamic 3D CFD simulations to optimize both the design and the shape and the efficiency inside the water. We found very interesting numbers, and therefore we went on, and in just 3 months we were able to build the first full-scale demonstrator, reaching TRL number 3 by March 2024. Here you can see the components in the lab and the fully assembled first proof of concept that was reached just a few months ago. The next phase was the actual testing phase. By April 2024, we were able to test in the laboratory environment, TRL number 4, both at the bench test, so by assessing the performance, the power and the efficiency of the electric configuration, the motor and the transmission, and in a water tank that was made available by our university to actually measure the effective efficiency that we could reach and verify that it matched what we expected from the simulations. There were some redesign phases to further optimize the entire concept, and then we were ready for the next step. That was tests in a relevant environment such as the sea. So we spent a whole month by testing the full boat with this concept and by comparing it also with other commercial solutions to define the benchmark and validate our approach. So here we are now, beginning of July. Our boat is just in the harbor, and today we also showed that it actually can confirm what we saw during the tests. This morning, we filed an application for a patent. So we got the patent protection. There's going to be a couple of months to verify whether the patent can be extended both in Italy and internationally. And the next step, if this process provides us with the right answer, is going to be to establish a spin-off of the University of Bologna based on this concept and the corresponding patent. So now we can present it to you because we have protected the idea. Why a spin-off company? For two reasons: to take advantage of the intellectual resources of the institutions and provide the opportunity for the students that develop this concept to jump on board the new company and go to the market. Following phases will be essentially in May 2025, we think we can define the production process by choosing what to make and what to buy, and strengthen the supply and commercial partnerships. Then, by September 2025, we think we will be able to industrialize the production process relying on supply partnerships for materials, components, and machining, such that we could reach the market by 2026. We think that this time frame is fully compatible with the Prince Albert II Foundation Award, because we would be able to update the Yacht Club of Monaco every 6 months about the progresses that we will be doing. And of course, the first market that we will initially target is going to be the Italian market, but we already have a marketing plan in mind to extend it to, let's say, the entire world, hopefully. This is it. This is computer, and this is part of the team that worked on this project. Here you can see a picture of the prototype, but we would like also to show you the actual demonstrator. This is one sample. We have another sample in the boat that is actually running in the water. So thank you for your very kind attention, and we are here to answer to your questions.
Congratulations to the professor and to all the team, because I am saying since 5 years that we need to design a contra-rotative propeller driving train, so very happy to see that it's arriving. I am a board member of several companies that are developing in outboard and electric engine, so I can maybe give some question maybe for my colleagues to see if that's a good one to invest with it. Could you please, I give you many questions, and after you reply in the sense you want. Could you give us an idea about the kind of application between engine, let's say boat, electric boat, motorboat, and sailing, compared to the existing, because there is also new existing outboard engine with a new kind of propeller, not anymore the standard propeller, but also like a biomimetism with a fish and many other things, which are a lot more efficient compared to the standard propeller. And also, could you give us an idea about the power range you want to have with your engine? The power range in between 5 kilowatt to 30 kilowatt, or the power. And where if you will just remain a company about outboard engine, or if you will pair with a battery. Sorry, that's a lot of questions, but it is important for us to understand all these pictures before giving the grant.
I prefer to answer the second question, because the first one I didn't understand it very well. The second answer, this one is a 5 kilowatt rated power electric motor with 20 kilowatt peak power. So, and we calculated that the amount of efficiency you can gain with this solution can vary from 10 kilowatts peak power to 100 kilowatts peak power, because of the configuration of the transmission. And that's it. Can you please repeat the first question?
The first was a kind of application. You want to sell this to who? To someone that has an outboard engine, and you want to replace his thermal engine by an electric engine. You want to address it to sailing boats. I have a sailing boat. I would love to have this kind of engine. if the propeller can replace themselves. So that's a question. What kind of application you want to target?
Well, we have in mind a few possible applications. One of them is to establish some partnerships with companies that produce boats, small boats typically, either catamarans or small sailing boats, mainly foiling applications. That could be another point that would be very important for the clean water and the actual effective greater efficiency that you can reach. That could be one marketing opportunity. So to define partnerships with companies that build a boat, and we can provide the outboard motor, but as maybe I'm answering also the other question, we could also provide the entire powertrain package. That could be also the battery and the inverter, so that we would provide a kit that could be just installed. And this kit could also be sold to private customers. And we would also supply, let me say, the installation facility and the maintenance and all the things that are needed. So these are, I think, the two main targets that we are heading to. Then there was another question maybe, or?
It was a range, you know, if you want to create a company and address a need on the market, you need, okay, I have a product ranging between 5 kilowatts to 30 kilowatts. Okay. So you answer because of the peak, you know, but when you buy a 20 kilowatt engine, Mercury or Suzuki or whatever, you just have this kind of power. So that was a question about, okay, maybe you want to address the market with range.
On that question, I would like to add one more comment. Depending on the power range that you want to sell, so the range is between 5 and 100 kilowatts, that's what we think. But depending on the specific power that the customer wants to buy, the battery would be essentially designed, not designed, produced to match that kind of power. So we designed essentially a modular battery system that would give you a certain amount of energy, but specifically different voltage levels depending on the power you need. So you can go down to low voltage up to 48 volts for the small power applications, and then you might need to increase up to 96 volts as the configuration we have in the boat here in the harbor if you want to have higher power.
Hello, yeah. A quick question from me. So do you have in mind, so you will create a company, do you have in mind like the next products you would build with this company, and how you would expand maybe the range of product or not? Or, yeah.
Thank you, that's a very interesting question. As I said, one first product could be just the thing you see here, okay, the outboard electric counter-rotating tractor propeller motor. The next step could be to sell the entire powertrain kit. And that could be a next step, let's say, to increase the market share and to also increase the revenues of the company. We are not thinking to start building boats at the moment.
Some question. So first, congratulations for the presentation and for the overall concept of really how to go to the market. So you're really working on a clear path to reach. My question is, have you done any comparison? If you see the total cost of your system, because obviously you need an electric motor, you cannot leave a wire on shore, you need to have also a battery and inverter. So you have, for a certain specific power, obviously some hypothesis of cost. When you compare your solution to an internal combustion engine, how much more higher first cost you will have? Do you have any idea?
Yeah, we did this comparison. I don't know, Jacob, if you want to add something, but what we see is, of course, this would be a premium product compared to a standard, let's say, internal combustion engine application. The delta cost for this power range would be a few thousand euros, roughly something about 8,000 euros if you think about starting by 8. So I try to be clear, somewhere about 5,000 to 8,000 euros more than what you would spend. That means something about 50–60% more than what you would spend. Okay, it's more or less our assessment. It should be refined, but this is what we thought. maybe one more thing, we did a benchmark with other products that are similar to this one. So with electric outboard motors without this configuration. And in that case, we think we can be, well, we verified that we can be very competitive, and we can produce this component and sell it at a significantly lower price than what you can find in the market today.
Okay, thanks.
Last question. Thank you for your presentation. I have just one question. So we see that you have a clear plan for the future. If you receive the grants, where you will use it exactly with your plan in the future, in the creation of your company, what's the plan to use the grants? Thank you.
I don't want to answer all those, but we discussed all those things together, so I'm answering for the entire team. Okay. We have a clear idea about that. Part of this budget would be spent to complete the patenting process. So we filed an application, but we still have to go through the costs, especially for extending it to the entire world. Part of the cost, part of the budget would be spent to establish the spin-off company. And then we will keep part of the budget to create an event to promote this idea, the solution, and essentially to bring on board investors such as business angels or venture capitalists or things like that. Thank you. Thank you again.
Thank you all for being so attentive during the last 2 hours and being here with us as we check out these fantastic innovations that we keep receiving at the Monaco Yacht Club. I invite you all now to head back downstairs, back to the paddocks to enjoy the rest of the atmosphere. And there is an e-sport championship going on downstairs. You can go quickly check that out on the way. The teams are participating and it's a good time. Thank you very much. Have a good end of their day.